So today we will be talking about the connected car data platform that I and my team have been developing at Mercedes-Benz. So let's go over the overview of this talk. So I'll be talking about the data sources, and then we will go over the topic of data privacy. We will look at the high-level architecture of our data platform. And then I will go deep into one specific topic, which is data unification module, which is a smaller part of our overall architecture. And then I'll let you know about our future plans. And then towards the end of the presentation, we will have some time for any questions that you guys have. OK, so starting from data sources. So Mercedes-Benz vehicles are driven all over the world, pretty much every single country. So you can imagine that we receive data from all of this different region, and our data strategy has been divided into 3 main regions. So our first region is America and Asia Pacific, second region is China, and third region is Eastern and Central Europe. And the reason for having the reason why we have 3 different regions is because we have a different data privacy and data regulations rule in each of these regions. For example, China has completely different rules and regulation as compared to what is being accepted by Eastern and Central Europe because of the GDPR, which is introduced in May of this year. So overall we receive data in different regions. Now, in each of this geographical region, we receive data from different models of the car. So let's talk about different models. So our sedan has a different software in the head unit as compared to our SUV version, which is GLE. And then same goes for each of these cars have a different version of software being introduced every year. So for example, the software version which was introduced in 2017 is going to be a little different than what will be introduced in 2019. So what I'm trying to say is that even if it's the same car, we have different data version. And then we receive data from different sources, from within the car and then from outside of the car as well. So you would think that what's the source outside of the car? So Mercedes-Benz has an app which is called Mercedes Me app. And what this app does is that it basically provides an interface between your car and your mobile. So some of the feature that has been introduced in the European region by this car is that you can simply say park and unpark from your app, and then your car will be parked and unparked. And this is yet to be introduced in US, but I guess it will be coming soon. So overall, we have these different variation of our data sources. So we have a lot of data sources. Okay, that's a good thing. But then being a customer-focused brand, what we want to really take care of is customer privacy. So we do not want to ingest or receive any of this data unless we have received a consent from the customer. So even our entire data ingestion starts only and only after a customer says that, yes, use my data for your product improvement. And then even after we receive the consent from the customer, what we want to still ensure is that the way we are handling a customer's data is in a customer's benefit. We do not want to make any anything out of it unless the customer is the end goal of our product. So the privacy and the security is handled in a really secure manner, in a really proper manner. So what I mean when I say this, so we do not persist any PII. We do not persist any information that can be traced back to any individual customer, any information that can be tracked to the location of any individual customer. So before we persist any of the data, we get rid of all of this, all of the information, and we have excellent anonymization strategies in place to be able to do that. And then that being said, let's move on to the architecture of our data platform. So what I'm showing you here is a very high level architecture because I thought that for the purpose of this talk, I'll go over just one module and then we will focus mainly on that. So as I said earlier in this architecture, we first of all receive a consent from a customer via the Mercedes Me app. Once we receive the consent, we start receiving the data from the car. Car starts sending telemetry data to us. What telemetry data is, basically in the head unit, when an API is being called from a function, we log that function. And that's what being sent to our backend. And then we receive some data from Mercedes Me as well. And this data is forwarded into a data unification module. The purpose of this unification module is that when we receive from the data from like all of this like different variety of sources, for our data scientists to analyze this data in a way that like which is easier and efficient for them, we want to homogenize it in a way that like where every row on our final data store makes sense, like is one data point and then is kind of a repository for like all of the information that happened in like those few seconds or those few minutes. And as I said earlier, we persist the deduplicated and only anonymized data in our persistent storage. And then once we have this data in our persistent storage, this data can be accessed by our data scientist, and then they create suggestion for product improvement. So now talking just about the data unification module. So I've taken like a small example here. So we receive telemetry data version 1. Let's say that this is coming from like one of the model of Mercedes-Benz, which is E300, and the telemetry data version 2, which is coming from another model, the SUV GLE. So what we do is we combine all of this data together, and then we create one data store which we call telemetry data. So here we have all of the telemetry data coming from any vehicle formatted in a way which is homogeneous basically. And then we combine this data with the data which is coming from the app. Once we have like all of this combination done and all of this data transformed and cleaned and parsed, we finally store it in our persistent storage when it is ready for our data scientists to be analyzed. And then here I'm just showing you a small code snippet. So for our data unification module, we use Spark and SCALA. And I'm showing you an example where I'm using like a with watermark feature of Spark. And then like we are talking about like data unification, and like I'm sure that like this is like pretty easy to be done. Like if you have to write a Spark batch job, you write it, and like you can understand that like it's doable. It's nothing rocket science. But then the challenge that we are facing at Mercedes-Benz is that because of the GDPR and our commitment to privacy, we do not have a lot of time to deal with this data. We hardly have a window to do all of this, data ingestion, data cleaning, data parsing, and then do the anonymization in the end and persist it. So all of this unification is done in stream. So from the time that a data point is generated in the vehicle or on the app, the data is ingested, unified, transformed, anonymized, and stored within a few minutes. And I think like that's something that I really take proud of. Okay, yeah. So so in the second block, I'm doing a join here, which is based on an ID. So this ID depend on the source of the data. For example, like every vehicle has a vehicle identification number. So if we do this join on the basis of vehicle identification number and then like the timestamp, so what we have analyzed so far is that for the amount of data that we are dealing with, I mean, you can imagine like as many cars that we have running globally, and then so the amount of data that we are dealing with, it kind of affect our data storage, that how long do we want to hold this data in a Spark in-memory frame, data frame, or in the cluster. So these are the number that, I mean, like, these are just an example of like what usually work for us, but then like we always play around these numbers and then like see that like what makes more sense in terms of like joining these data set together, and what makes more sense for our data science to have a unified data. SCALA is our preferred language of programming for all of our data platform development. So we have developed, of course, like Spark and SCALA, and then we very recently started doing something. So we were writing a lot of UDFs in SCALA, and then it happened that sometime like a UDF which is like needed for this kind of transformation is the same which is needed by another kind of transformation. So what we have done is that we created a SCALA library, and then what we do is we internally do releases of the SCALA library, and these UDFs are very specific to vehicle functions because, or to vehicle domain. And then we share it across like the other team members, and then this has been proven useful for our data scientists as well, because like when they analyze the data, they also like find it useful. So we have been like doing this internally. Eventually in future, maybe we might as well do an open source of these libraries. So that's something that we want to do in future. Now, so I talked about the future plans of the data engineering team. There is something that Mercedes-Benz started doing recently is that we are, I and my team, we are currently working to implement an ISO standard which is called 20078, and I'll go more in detail about this protocol. So what this standardization is, that this is a way of creating API specifically for the OEMs to share this data through, to any other third party or any other entity across or like outside the organization. And the reason why we feel that like it is important for like any OEM to like work on this kind of standardization is that in future, these API will be able to provide an interface between the third-party apps on your vehicle by somebody else other than the OEM. And I feel that like that is a space which is yet to be explored by a lot of like car makers, and that's why like we are rigorously working on developing this. And then one thing that I want to like address back is that while we are doing all of this, still the main focus of the brand is to keep our customers satisfied, and not just satisfied, like give them the features, give them the product which really makes their life easy. And like build a community basically where our customer enjoy their car even more. Thank you. Any questions?
So when you record the data, like you have kind of images, right? Is it? The telemetry.
So,
It's kind of imaging data.
It's all kind of data. So it's data which is coming from sensors, data which is coming from the API internally, but not necessarily image, because this data platform that I'm talking here is not necessarily the autonomous driving platform, but this is the data layer of the autonomous self-driven car.
What's the sort of order of magnitude data transfer, like from each car, like per day?
So the head unit sends the data only and only when the car is in operation, and not when the car is parked. At an average, we receive data about, I think like we receive data every few minutes, and then it also depends on how much of activities is being done in the vehicle. Like for example, like how many times a feature is triggered, how many times certain action is being called. So it depends on the data size as well. So, but then overall, like the data volume that we receive is pretty huge. So when I'm talking about data volume, so I'm talking about like the data coming from each car multiplied by number of car multiplied by globally. I do not know the exact number.
I guess I was just trying to get a sense for like, it wasn't clear, is it that you'd be dealing with the AVs, or are you dealing with the regular, is it like telematics, or is it like the AV data?
So it's telematics data, and then this is, so this is not for the cars which are like driven like until 2017. So this feature only like started from the cars in 2018, and then in that as well, like the cars which can be connected through Mercedes Me app. Okay, thank you.